All right, ladies and gentlemen, I wanted to give you guys a little bit of help with the parallel circuits, just in case you happen to be working on this assignment tonight and you're struggling. So I'm going to do number 9 here as an example, and then the way this worksheet is set up, they're all pretty much the same, just numbers are different. So the first thing that the sheet asks us for here is RT, or resistance total. So we have two resistors, a 300 and a 600. And we learned in a parallel circuit that resistance total is always less than the smallest resistor. So this is 300. So I already know my answer should be less than 300. So if you remember our formula, it's 1 over RT equals 1 over R1 plus 1 over R2. So 1 over RT is going to be 1 over 300 plus 1 over 600. So 1 divided by 300, 1 divided by 300 is 0.003 plus 1 divided by 600, we're going to call 0.0016. We're going to take these two numbers, 0.0016 plus 0.003, and I'm going to get 0.0046. So 1 over RT equals 0.0046. Now this is where some people make the mistake. They write that answer down thinking that they're done. Remember, this is the reciprocal method. This is not a common resistor size at all. That's like less, 0. So that doesn't even make sense. So to take the reciprocal, we got to move that 1 over there, and RT is going to be 1 divided by 0.0046 equals 217 ohms, which is less than 300. So we're in pretty good shape here. So 217 ohms is going to be our answer. I is V divided by R. Our V is 200 and our R is 217. So 200 divided by 217 is going to be 0.92 amps. Now, to find the two individual currents in each one of these resistor branches, we're using the same formula. I is V divided by R, except our R is not going to be RT this time. It's going to be each individual resistor. So it's going to be 200 divided by 300 and 200 divided by 600. So let's do 200 divided by 300, which is resistor 1. And we get 0.6, we'll make that 0.67 amps. And R2 is 600, so 200 divided by 600 gives us 0.33 amps. If we take 0.33 plus 0.67, we see that we get about 1 amp, which is pretty close to what we had up there. These answers should always be pretty similar. These two R1 and R2 currents should add up to our IT or be really stinking close to it. So that's how you solve a parallel circuit. The hardest part being that formula for RT, but the rest is pretty easy. So hopefully that helps you out. Good luck.